Hi, hello and welcome to HK Form for Parabolas, an overview. In this video we'll be taking a look at one of the most common forms for parabolas and what we can learn from this form or how we might be able to derive the form from a graph. So let's take a look at a few examples and some basic ideas first. I do think before we get going on understanding the HK form that being sure we understand what squaring something means and also what a basic parabola shape is will be helpful. So let's just look at squaring. If I take 3 and I square it, this gives me 9, so it makes something that is larger than 1 even bigger. If I take something like 1/2 and I square it, then I get 1/4. So if you take a small number and square it, it actually gets smaller. So that's an interesting thing. And if I take a negative number and I square it, I end up with a positive number. So no matter what I have inside of something squared, no matter what is in there, I can never get out a negative number. So this always equals something positive or, and this is the important part, or 0. And 0 is the most important part for us because it'll tell us a lot about the basic parabola shape. So if whatever is in here is equal to 0, 0 squared is 0. So whatever I square, when that's 0, then I should be at the lowest possible point of a basic regular parabola. Now if we have some constants on the parabola, so we have something like a negative 3x squared, that's going to be quite different from y equals 3x squared. So these are quite different ideas here, and in the video ahead we'll be exploring how these are very, very different. But keep this in mind, this idea of squaring 0 and getting 0, and that in general large numbers being squared get even larger, and numbers that are small, i.e. below 1, get even smaller. Now the basic parabola shape that we all have come to know is this kind of a U like this. And it can either go up, as this one does, or it could go down. But it can't go sideways in the normal form. If we have y equals a, quantity x minus h squared plus k, we're always going to have either a right side up parabola or one that is facing down like this. Alright, so we'll get on with the next part of the video. Alright, now to get us going, we're going to work slowly up to the HK form and just go one step at a time. So we'll start here with just y equals x squared, and let's consider a nice simple example of y equals x squared without any coefficients, without any strange things going on. This is our basic parabola, and if we consider what is being squared, again we talked about this idea that large things being squared are larger than themselves, and 0 being squared is 0. Let's also note that 1 squared gives me 1. So if we go over to our parabola, we can note that when we take x equals 0, maybe make a little chart over here. If x is 0, then y is going to be 0. That's nice. And if x is 1, 1 squared is 1. If x is negative 1, that will give us 1. And then we could maybe add a few other numbers in, perhaps 2. 2 squared is 4, and negative 2 squared is also 4, and 1/2 squared is 1/4, and finally negative 1/2 is negative 1/4. And let's put our red line all the way down there so we can see these are some options. There we go. So that's going to mean that our parabola, which we all kind of have some experience with, this nice shape here, has the shape that it does. That we know that it goes through the origin at 0, 0, that we have some critical points here at 1, 1, and we also have a critical point over here at negative 1, 1, and the one we're after with HK form is right here, and it's this 0, 0 point. So oddly enough, if we take a look at y equals x squared, it fits this idea of HK. If I took x minus something, really it's x minus 0. So there's this idea that the vertex is at 0 and then plus something. Well, I'm adding 0, so I'm at 0, 0. So even when we compare this to that original form of y is equal to a times x minus h squared plus k, and the writing's coming a little behind me here. We'll see that just emerge as I go. One can see that it does fit the form, although a little strangely because it's so simple, of giving us this idea that the vertex is going to be at h, which is 0, and k, which is 0. That's a good start for us, and now we'll make the project a little more complicated by adding some subtractions, some additions, some multiplications. Now we're going to start to move along a little bit here, and let's consider what happens when we add something to the basic form of x squared. So a nice example might be something like y is equal to x squared plus 3. Now we used to have points on the original curve that were 0, 0. Now we're going to have 0 still for x, but we're going to add 3. So a little chart of values might look now like 0, and instead of 0, 0, we're going to have 0, 0 plus 3. And we'll be doing this for all of the values that we used to have. So all of the y-coordinates will simply be 3 higher. And what that's going to mean is that our original parabola, which used to be at 0, 0, here's our old x squared, is going to get shifted up 3 points in every possible spot. So 0, 0 moves up to 0, 3, 1, 1 will move up to 1, 4, negative 1, 1 moves up to negative 1, 4, and we have a new parabola right here, which is x squared plus 3. And we can see that again we'll follow the general form of HK by noting that in our problem so far a is 1, h is going to still be 0, and then finally our k is going to be 3. And so our vertex is still at this h and k, which is right here, and that spot is 0, 3. Now this example is the one that's going to make I think make that idea of what we're squaring equal to 0 very useful. So let us consider the example of y is equal to x minus 3 squared, and see how this helps us with the parabola. Now we agreed that if we kind of think of what squared is equal to 0 will give us 0 out in general. So here's this idea that something squared equal to 0, well, this stuff in here would have to be 0. So in order to get 0 out, I would have to have 0 be all of the thing that was squared. So we could ask ourselves what would make x minus 3 equal to 0, and that's going to be x equals 3. So at 3 I should be getting 0 out of this thing. Now let's take a look at the HK form and make sure that that makes sense as well. So right now we have y is equal to a times x minus h squared plus k, and in our problem there is no k, so k is 0, so the y-coordinate of the vertex should be at 0. This h is 3, so I should be at 3, 0, and this makes sense with this idea of what I'm squaring, that it would be all of these things equal to 0 to get 0 out. So our new parabola should be shifted over, the old one sitting there is now shifted over to 3, 0. And the HK form, this fancy idea, matches up with just some basic thinking as well. And I hope that by the time the video is done, that you won't be worried about this form, but you'll in fact understand it. Not something to be memorized, but something that just matches with the thinking you already have. And that seeing why the vertex of the parabola is at 3, 0 will make total sense to you.